that's fine. So I try to speak. So good morning, my name is Cristiane Bandeira de Mello, and first of all I would like to apologize because a lot of mails were exchanged and I didn't saw them because I was part out of the internet, I was traveling. Last month for me was really crazy because I was last year I was out on a sabbatical leave from my university, and now I just returned from Boston 2 days ago with my kids. It's a mess right now. Let's do that. I'm going to try to very quickly present what we do in our lab, so to see if you are interested in. Okay. I'm from Federal University from Rio de Janeiro last year, few years. I'm originally from Philippines. I did all my graduation and post-graduation there. So that's why I have a very strong link with Clarissa and mostly with Patricia Rosa. It's like my home. So I feel very comfortable there. And in Federal University, I still sometimes feel that I'm an outsider, but I've been there for 8 years now. So I work with eosinophils since my graduation, and initially I used to work with rat eosinophils. And then I went to Harvard Medical School and worked with Dr. Peter Weller. That's a very important name in area of eosinophil biology. I started work with human eosinophils. And so, although I have several interests concerning eosinophil biology, a main focus of my group it's the ability of eosinophils to produce inflammatory lipid mediators, mostly eicosanoids. So we have been studying the mechanism involved on the eicosanoid synthesis by eosinophils and also the effects that the eicosanoids have on eosinophils. So that's what we know how to do in our lab, in my group at least. And so eosinophils, what people know about it, that they are very prominent during allergical reactions in asthma, for instance, and they are said as effector cells on asthma, so they are responsible for inducing the symptomatology, for instance, that you have in asthmatic patients. They are also they are also recognized by their ability to kill worms, like Schistosoma amazoni and this kind of worms. So they have this protection ability against this kind of infection. And more recently, a new role for eosinophils have emerged. So they are now considered also immunomodulatory cells because they have the ability to synthesize and secrete cytokines. They can present antigen to lymphocytes. They have really special abilities that are not very well described and recognized. So as I was saying, the thing that we do routinely in our lab is to purify human eosinophils from health donors. And usually we start doing our questions and our studies with that kind of cells, so human cells from a health donor. And you spend like 5 hours isolating these cells because from health donors you have very few circulating eosinophils, so you spend a lot of hours to isolate them, and at the end of isolation you don't have too many, but you work with that and you can study the ability of eosinophils to secrete something or synthesize another thing, and how you can modulate that, what drugs can affect the cell, this kind of thing. And to reproduce what we are seeing there in here, and if we can, then we move, that's our methodological strategy in our lab. We move to in vivo models to see relevance, what we were seeing in human cells in vitro. That's how we work usually. And just to exemplify, this is something that we showed some years ago, using this kind of strategy with human eosinophils. We were able to show for the first time that eosinophils can be stimulated and produce prostaglandin D2. So this is the other, I think, key word from my group. So definitely eosinophils, but then if you are talking about eicosanoids nowadays, I really work with prostaglandin D2, okay? So this work was important because in the past, mast cells were the only cell recognized to be able to produce this molecule. And now we know that it's not mast cells, not only eosinophils. It's a small group of cells because to produce this molecule, you need to have, you need to have this enzyme that's really a restricted enzyme, is expressed by few cells. And for once released, PTD2 works through activation, not exclusively, but mostly by activation of two main receptors that we pharmacologists call DP1 and DP2, immunologists call DP2 CRPA2.